Ready to learn how to use OpenCV with ROS? Right, this is the place. This is the ROS Developers Live class. Let's start. Hello, ROS developers. How are you doing? Here during the confinement, I hope that you are taking this time to learn a lot and to take a lot of profit while you are confined. So you are reduced in a very small space, so let's try to make the most of that time. And that is what we are going to do here today in our live class. Okay, so today, as you know, we are going to use OpenCV in order to control our robot. So we are going to see the basics of this behavior, okay? We only have 1 hour of time, so we cannot go very deep. I was checking the comments that you have been putting on the chat at the beginning of the class, well, before we started class, and there was a very interesting comment by, let me check it, is the comment by somebody was saying, I hope that this live class is going to help me to manage my industrial robots with OpenCV. Okay, yes, get excited about the class of today, but not too much excited, yes, because, I mean, we are going to see the basics today only. Okay, so, but it's good enough to control a drone to follow a line that is written, that is drawn in the ground. Okay, so that's what we are going to see today. And before starting with everything, let me say hello to all the people on the here today. I can see that we have more than 100 people. This is record. Never had so many people on the live class, so I'm very, very happy that you are all here. Of course, you are all of you welcome. The only requisite here is to come here to learn a lot. Okay, so I hope that you are going to learn a lot. If you have questions, go to the chat and put your questions there, but they have to be questions related to the subject of today, so what we are checking, okay? Imagine this as a class that you are doing at your university. It's the same. The only thing is that it's virtual, okay? So don't get your questions back in your mind, put them on the chat, and I will try to answer as much as possible. It depends. So we are getting a lot of people, more people is coming. That is great. So you can get in. So we have a space enough. But yeah, so put your questions there and don't keep your questions in your mind. So I would like to say hello to all the people, the early ones. So we have Shiham, Navid, Sanket, Wodong. Then we have Mehmet. Also we have Thomas, Miguel Menendez, hello, Boshan, then Suhai, Connor Crawford, and we have Farhad. That's the guy who asked about the implemented OpenCV in industrial autonomous logistic vehicle. Very nice question, Farhad, but we'll have to go step by step, okay? Then deactivated account is also here. That's nice. Your names are amazing. And then Lagan Kapoor, of course. Lagan, hello, how you doing? As always. And yeah, many others. So their compute, their compute has arrived. I didn't know that you were going to be able to manage to attend. So happy. And also so happy for all the others. So you don't have to say hello here. I see that you are saying that. Thank you very much. But if you feel shy or something, just stay there, but pay a lot of attention, okay? So what we are going to do right now, is I'm going to share with you a project, a ROS project, okay? We call a ROS jet. And then I'm going to copy a link on the chat, so you are going to have to click on that link. Then by clicking on that link, you are going to get a copy of my project, the one that I have created for this live class, and you are going to open it. I'm going to show you how, okay? You don't need to install anything in your computer. Everything is handled on the web. So don't worry, it's very, very easy. So you click on the link, you will get a copy, then you open, and then you start practicing with me at the same time, okay? So you have to do the same things as I am doing on the screen and explaining. And if you feel confused, something doesn't work, you didn't follow, whatever, raise your hand, put your question on the chat, and then we keep moving from that, okay? So let's start, because today we have a lot of work to do also, as always, and I need to finish in time. So let's go. Then there is a final comment here that I can check on the chat that is from Engineering Nation that says, I can change my name, but wanted to. Okay, very, very nice. Okay, it could be worse. You know, it could be worse. Your name, your nickname could be worse. So Engineering Nation, it's cool. Then let's go. Let me share with you my screen, and then you will see how I copy this link and I share this link with all of you. So let's go to here. So this is the ROS Development Studio, which is the tool that we are going to use today. And here is the ROSjet, the ROS project I have created for today, and I'm going to share that with you by clicking here. So I'm going to copy this link, and I'm going to put the link on the chat. Okay, so it's going to be appear on your, it depends on the delay, yes. So ROSjet of the class is this one. Okay, so there it is, the ROSjet of the class. I have put it on the chat. Then you can click on the link. Then by clicking on the link, what will happen is that you will be redirected to the ROS Development Studio, and you have to enter with your free account. If you don't have, just create one quickly. So then you create this account, and then you will get a copy of this ROSjet. As you can see, this is my area. This is the area where I have many ROSjets created. So I have many, let me see, 256. Yeah, we work a lot. Yes, I confess. So then in your case, if it is your first time here, you will have only my ROSjet, the one that I have shared with you, and another one that with instructions that you can check later. Okay, so it's another one that is not shown here. So you don't worry about that. So it's very easy. What you are going to do once you have this ROSjet is to press into open. You can check the options later, okay? But now open, and then press open again. So let me know if you get a copy, if you get the option to open the ROSjet. Okay, so if you do that, then you will get this screen here, and then the machines are getting prepared for you, and the whole project is going to be prepared for you. Okay, so it's going to take a minute or so. In the meantime, let me go to the chat and see how is people. Then Mr. Randy Tom is asking, is this class about monocular B vision SLAM? It is not. It is not. The purpose of this class, I'm going to show you now when we open the core, the ROSjet. The purpose is to learn about how to integrate OpenCV with ROS. So how you can get images from ROS and then get them into OpenCV, so then later you can do whatever you want. As an example, you can do whatever you want, I mean, with OpenCV libraries, because OpenCV libraries are the state-of-the-art of the libraries in vision, in computer vision. So we want to be able to use those super cool libraries with ROS with the images that our robot captures. So that's the purpose. Then we are going to use this OpenCV in order to identify where there is a line and then make the drone follow the line. But this is just an example. This is just a case to show you that you are actually capturing the images from ROS, from the topics, and then getting into the OpenCV, manipulating it with the algorithms inside, and then generating an action based on that manipulation. It's a very simple example, okay? It's very simple, but that's good enough for the purpose that we want. And then what else? So I have here people that says Fusion Savage says done, Navid says ready, Bandula says open. How Liu, he says loading. Great. Okay, so I don't know why it's taking so much time in my case, so it should be already, okay, here it is, great. So here it opens, then we have another comment here from Curtis that says, sorry, Connor Crawford, he says, I realize you have this ROSjet built for us, but what's the best way to install OpenCV for ROS Melodic since there is no ROSified ROS Melodic OpenCV package? Okay, so that's, yes, so then probably you have to install from source. Then you have to install from source and then compile. You have to download the ROS Kinetic OpenCV package and then compile in Melodic and solve the errors that may appear there. Yeah, sorry, that's the only option. Then Bail says, it works with Robotics drone. Well, it depends. If your drone is ROSified, so if you get a ROS topic from your drone, then it's going to work for sure. Okay, so you need to have an image, a topic that publishes images in ROS, and you need to have a topic that accepts velocity commands, twist, that's it. Whatever, I don't care which robot is. If it's a robot that has those two things, then it's going to work. Okay, ready sir, ready, loaded, loading, done, very good. So we're still loading. Okay, so in the meantime that we are still loading, you can check my screen because we are not starting to do anything yet, just the introduction. Okay, so what I mentioned before while loading is that using OpenCV in ROS is very important because OpenCV is the state-of-the-art library with image processing. In algorithms for image processing is the best package. So it's very important that we can use this within our robots. So that is why we are going to show here how to integrate ROS with OpenCV, get the images from ROS topic and provide this to OpenCV algorithms. Basically, that's the core of this live session, okay? Okay, so that's the importance of this lesson. This teaches you the basics. And in order to be able to follow this class, you need to have some requirements. So you need to understand basic Linux. And if you don't have this knowledge, you can check later our free online course about Linux for robotics. The same, if you need to master Python, well, at least to understand Python code. We are not going to do very fancy Python code, but you need to understand how it works. If you don't have that knowledge, check this free online course that we have created. And then also you need to understand the basics of ROS, topics, packages, ROS CD, ROS launch, so on. If you don't know, please check our super cool online course. It's very good, step by step, using simulations on the cloud. You don't need to install. It's very good. Okay, so let's go. I hope that you are getting there. Then Angelina says the screen is blurry. I suppose that you mean the YouTube screen. So please check the settings on your YouTube. There is a screen. We are transmitting today at 720p. So you should see clearly the screen. Okay, so I have included here the simulation that we are going to use today. So let's go and let's start by launching the simulation. How do we launch the simulation? I'm going to show you the easy way, okay? Let's move fast. There are many other ways. Check our documentation for those. So go to the menu here on the top that says simulations. Click on there and then click on the blue button that says choose launch file. Click there, then it's going to appear there another select launch file dialog, and then you have to select there and select the start sim launch file. This is the launch file that I have created to launch this simulation. It is included, everything that you are seeing here is included into the ROSjet, so you can check the files later. Then press launch. So by pressing launch, you are going to get a new window that is loading the simulation. So let's see, and then at the end we should get one image like this. Okay, so what I am explaining is already explained also here in the notebook, which contains the instructions. So don't worry if you miss some of the details, you can check later also. So I'm skipping some of them. Okay, great. So we have the simulation here. Now, with the drone, I hope that all of you have. Okay, here is the very simple. So what we are going to do is to make this drone follow one of those lines that we have in this wall. Okay, so it's a big wall with some lines. You can use for many testing purposes, this simulation. Then let's go, and the first thing that we need to do is to make the robot get started. So we have the simulation, but the drone is on the ground. So let's make it move a certain distance from the ground. Okay, so the first thing that we need to do is to call this service, which is called engage. For that, where do we issue this command? Let's use a terminal. Okay, let's use a terminal. So for that, we need to launch a terminal here. It's going to Tools. In order to launch a terminal, go to Tools, do the menu on the top, Tools, click there, then select the shell. Shell, then we have a terminal here. Great. So here is the terminal. It's like your terminals, like Linux terminals. Then what we are going to do is to issue this command that calls to the service. You can copy paste directly or type it if you want. So I'm going to copy paste to go faster. So by doing this, you are going to see that the robot has engaged in some movement. Okay, it's like, oh, I have started, but now it's getting down again. Okay, don't tell me why it does this. This is how the simulation has been prepared. Okay, so it's getting into the ground and sliding a little bit, but it's going to stop at some point in time. Great, so the robot, the motors, is like the motors, they are spinning, let's say. Yeah, now, here, okay, so I have here a bad command. Don't take into account this command, which is about the Hector keyboard teleop. Those were some tests I was doing and I forgot to delete. So you can actually delete this cell completely. The one that says ROS run Hector, you can copy and delete because it's wrong. Then we need to put the robot at a certain point on top. Okay, so we are going to do a trick because I was trying to get some keyboards and so on, but didn't have the time. So let's do some ROS hardcore tricks to make the robot just to get up off the ground a little bit. Oh, sorry, I pressed the wrong button here. I don't know what I did. Okay. Let me refresh this. Here it is. Okay. So what I was explaining is you need to put this on top. So for that, we need to apply to the robot some speed on the Z-axis. You know, the Z-axis is the one that goes on the top. If you want to see the axis of this robot simulation, you can go, but take care, okay, by doing this, because you can mess the simulation. But go to this icon here with the cross of arrows. If you click there, then and you have selected the robot, you can see the arrows. So we can see that the red one is the X1 axis, the green one is the Y axis, and the blue one is the Z axis. So we want to move the robot a little bit up. Okay, but we cannot just do it like this, because then when we release, if I release, then it's going to fall down. Okay, it should. Okay. Okay, so I don't understand why now it's not falling. Okay, so yeah, okay, then I don't understand why it's not falling now. So yeah, something related to the simulation itself. Okay, okay, then it's easier. Then it's easier. So let's select the robot. Again, select the robot. You can see that when you select the robot, you have this white box surrounding it. Then that means that it has been selected. Then once you have that, select the arrows here. Now you can see the arrows now to move, and please take care when you move in this, because you can move the robot to some hyperspace and then lose contact of the robot, and then you will have to relaunch again. Okay, so let's move into the other side. So use the red arrow. So we are going to move the robot up to this point. Okay, let me make it bigger so we can see better. What I would like to put the robot is here in this area around here, because here we have a longer line. Okay, so let me select the robot, go back again to the arrows, and then move the robot in this direction, then the green one on that direction. Whoops. Yeah, so that's what I was telling you, that if you are not careful, then you can move the robot to a very stupid location. It's because of the perspective of the simulation. So let me move it like this. And I can see that, okay, that makes sense. It's because this is blue. This is blue. I think that something happened with my simulation, maybe crash or something. I don't know. Okay. Then let me relaunch my simulation, because this is not good. It's not good. So let me close the window and launch it again. So I'm going to do the same procedure again, because I'm not sure. I think that this is wrong. It was a blue icon here that says loading. I think that we were just managing the a crash simulation. So the simulation has crash, and then the 3D window here is remembering that. Okay, so I have the robot there again. I'm going to launch again the engage service. There it goes. So now I have the robot over there. And in the meantime, let me see the questions. I see a lot of people here. And then there is James Kaler, who says, I have the Panda simulation, not that simulation. That means that you have launched the wrong project. James Kaler, you need to launch this simulation, the project for today's class. Please go to the top of this chat and you will see the link to the project of today. Okay. And Gloria is putting some order about the questions. Thank you, Gloria. Gloria, for that. I couldn't see the question because it's moving too fast. And I mean, we are getting record of attendance here today, 159, about to be 60, and I cannot manage so many comments. So let me keep going and explaining, okay? So I have moved the robot, and now I'm going to select it, select the arrows and move it to the top. Then if I, okay, so fair enough. Okay, then let me move it to where I said. So I hope that you are doing the same. And I'm getting here. Okay, having some trouble. Yeah, here. Okay. Then I'm going to move it to the long line that I have here. I'm going to move it like this. Then I'm going to put it like this. So what is the purpose? The purpose that I want is to put the robot on looking when the x-axis, you know, the red one, which is pointing more or less to the line that we can see on the ground. Why? Because we want to see that the robot is going to follow that line. Okay, so now I have this robot, so I would like to know what the robot is seeing. So for that, what we are going to do is to launch the RBIS. You know the RBIS. The RBIS is we want to see this image that we have here. So with the camera, the information that the camera is capturing. So let's go to the terminal and then launch the RBIS. So you type the command RBIS that you have here in the notebook. Okay, so launch it, and then once you launch it, you will see that okay, so RBIS starts, but you cannot see the window of RBIS. Where is the window of RBIS in this graphical environment of the web? Then in order to see RBIS, you need to open a special tool that is on the top menu. So go to the top menu, select tools, and then select graphical tools. Then we see here, so here in the graphical tools, you can see that inside this window of graphical tool, we can see RBIS, okay? But for some reason, the RBIS is kind of occupying the whole screen. So you can move it by clicking there on the top menu and arrange it. And one simple thing to arrange it is do double click on the blue top bar of the RBS. Then it's going to automatically center so we can see the whole space. Now, we have to do two things here. First, we need to change the fixed frame that is pointing to map by default. We need to change here. So, wow, I'm clicking here some buttons and doing some stupid things, I think. So, click here on the fixed frame and then select the base link. Okay, so that's one thing. Second thing, let's do here is add, click here on the add button. So let's add an image. Let's add an image here. You go down, down, down until you select the image. Oops, selected something else, I think. Okay. Yeah, I selected a wrong one. Sorry. Very small. And it's like something is moving by itself. Yeah, sorry. It's not me. It's some interaction in some way. That let me remove those that I have added that are not correct. So let me add now the image. The image here, here. Okay, got it, the image. Then you open the image and you select the topic. Here on the topic, you have to select the camera RGBD image raw. And then by selecting that, now we can see what the robot camera, the drone camera is seeing. Now this is the image that the drone is seeing. So this is in this location, that is the simulation. The drone camera is watching on that direction, so is seeing this line here. So we want the robot to go on that direction, okay? So that's what we are going to achieve now. So now we can see what the robot is seeing. Great. So this is going to be a debugging tool. Then let's go. So let's start creating the code that we are going to use here today. For that, here I have the instructions. The first thing is that we need to create a package where we are going to put our code. And this package has to be inside the Catkin workspace. So let's open another shell, okay, another terminal. Go to Tools on the menu of the top and select Shell. So on this terminal, another terminal, okay, so if you get this message, don't get scared. That means that we are using a lot of the CPU. That is cool because we are making good use. And you can directly dismiss, or if you want to support us, you can check it now and buy higher CPU systems. But for the class of today, you don't need that. And most of the basic things, you don't need that. So press dismiss safely. Okay, so let's go to the Catkin workspace. So here in the user, home user, we have another several workspaces, and one of them is the Catkin workspace. So let's go to the Catkin workspace, and inside the source, remember Catkin workspace / source, go there. Okay, great. Now let's create the package, and let's create a package called line follower, which depends on ROS.py. You have the command here, okay, the first command. You can copy, please copy without the $sign. The $sign means the prompt. It's representing this prompt that we have here in the terminal. So Catkin create package, and then I have created my package. Is where I'm going to put all the code that I'm going to create here today. Great. Now let's go inside the package. cd line follower / source, and then inside there, inside the package source directory, we are going to create a file that is going to contain our code. Create the file touch, just a file, touch controller.py. So we created this file, and we are going to populate this file with our code in a minute. Okay, but before that, let's provide execution permissions. So for that, chmod +x to the file controller. Okay, so what I'm explaining are all those commands that you can see here. Okay, so don't worry, they are there. If you forget, if you don't know exactly the commands, you can copy paste. That's it, these simple Linux commands. So now let's go and let's populate this controller py file with the first part of the controller that you can see here below. Okay, so how are we going to do that? Well, we are going to open the IDE and use the IDE in the tools menu. And I can see here a comment by Curtis that says, come on, Nano is not installed, dude. Yes, so I propose you, Curtis, that you use the IDE by now. With Nano, we were having some trouble in the integration with the shell, with the terminal here, because it's quite tricky. And that's why we had to uninstall until we solve those problems. Sorry, Curtis. Go with us now with the IDE. Sorry for that. So let's go to Tools and select the IDE option. So now when you select that, you can see that it's going to open here the IDE with all the workspaces that we have in our ROS yet. Actually, the simulation code is here in the simulation workspace / source. You see the drone inline. And then our code is here in the Catkin workspace / source. Then we have the line follower package, and inside the source we can see the controller file. So do a double click on that controller file, Python file, and then let me put it like this so we can be copying and pasting code. So the first part that we are going to do is the main part of the controller, which is this code here. You can copy directly, select everything, and then copy, come here to the controller and do a paste. Do a paste. Okay, so what is this code doing? It's very, very simple. It's just creating a line follower class that has a subscriber. This subscriber, camera image raw, is the topic that you remember, is the topic that we selected here in order to see the camera. So that is the topic that is going to provide us with the images. So we subscribe to that in image sub. Okay, and then that's the callback. Here we can see that we are providing a callback for that topic. And the callback here is empty. We are going to be populating this callback right now. Okay, then we have the main one. The only thing that it does is to create an instance of this. So by creating this, the subscriber is generated automatically, and then we initialize the node of the node, of the program, and then we start a spin. So our program is going to be spinning all the time here until we get an interruption from the Control-C. Okay, great. So now, what do we have? We are getting images here in image soup. In this code, we are getting images in this image soup that are coming from the image raw topic. Great. So now let's go to the first part, which is the one that converts the ROS image that we are getting from the topic into an OpenCV format object. Okay, so for that we are going to use one thing that is called the CV bridge, which is provided. It's a tool which is provided by the Vision OpenCV package. It's a package in the ROS repo. And by using this CV bridge, you are going to see it's very simple to convert automatically an image raw image data in the message type that is an image. So that's the image format. Yeah, I know all the names are the same. Yes, sorry for that. Could be a little bit confusing. So this image type of message is going to be converted into a CB image. That's the type that we are going to use. Okay, so how do we do that? Very simple. First, we need to import some extra stuff, which is the CB bridge and the CB bridge error. So copy this line to import this from the package CB bridge. So copy this, and then you have to put it here at the beginning of the code, so where all the imports are. So that's why I mentioned that you need to understand Python a little bit. And I can see that you have many questions there, but my colleagues, Alberto, Miguel, they are answering your questions. They're supporting me. Thank you, guys. It's my super team, because otherwise I cannot do both things. Too many questions. We are reaching 200 people on the class now. Just right now, we have 199. And that's our top record of classes. Thank you very much, people, for the confidence, for trusting us, for learning you. Okay, so let's continue. So we have to include this, and then we have to create a bridge object. Okay, so we need to create a bridge object. This is the one that we are going to use to do the translation from ROS message type into OpenCV message type for the image. Okay, so copy this line, self bridge object, and this self bridge object has to be part of the init part of the class line follower. So you can put it safely, for example, below self image sub there. So, but take into account the indentation. That's very important in Python. Remember that. Okay, so you have to follow the same indentation as the previous element. Okay, great. Now is when we are going to put the first lines inside the camera callback that now has only a pass, nothing in there. So we are going to substitute this pass by this code, which is the one that creates the image in OpenCV format. So copy this code. You can copy this, Control C, and then put it here to substitute this pass. So I have deleted the pass and I have put this new code. Okay, that is the one. Basically what it does is uses the bridge object that we have created here, this bridge object, which is a class provided by OpenCV, the CV bridge, and then it converts the data. You see, data is the image that it's coming from the callback. Okay, so this is the callback of the camera that we have here. This is the callback. Then we get an image from the topic, and then this image is put here, and we convert into BGR8 format of OpenCV, BGR8 format of OpenCV, and then we get the image translated here. So from this point, whatever we put below this can use the libraries of OpenCV on the image that is being captured. And I can see here a question from Arthur that says, this is Python 2.7? Yes, it is 2.7, because we are using ROS Kinetic. You can check the configuration here on the top left corner, ROS Kinetic, Gazebo 7, Ubuntu 16. So that's the configuration that we are using in this project, and that project has still working ROS Kinetic with Python 2.7. Okay, so now let's go to the next step. We have converted the image from ROS into OpenCV. Now we have done the most difficult part already. No way, that was the easiest one. So now we have to start detecting the line. So we are going to work on detecting the line. And for that, we need to import some things that we are going to use. So NumPy, in order to create some arrays and do some operations, mathematical operations, and CV2. CV2 is the libraries of OpenCV that we are going to use for converting and detecting the line. So you can copy all this, import CV, NumPy as NP, copy that and put it here at the top of the code, here, together with all the imports. Okay, great. Now, let's scale the image down. So, in this case, I put here a 20, but I think that we had to put a 60. So let's put a 60 instead of a, yeah, sorry, I did it too fast. It's because I'm thinking at the same time based on my experiments and so on. So what we are going to do in this step, let me go slower. So in this step, scale image down, is that we are going to reduce the size of the image, because we don't want to work with all the image if we don't need it. You know, if we don't need it, then we would like to avoid to have as a large image in order to reduce the processing time. And this is going to be very important as you keep working with OpenCV, because then the algorithms, they take a lot of time And the larger the images that you are using in every step, then you are taking a lot of CPU and making the process slower. So before we start processing anything, we want to take the bare minimum image that we can use in order to accomplish our goal. And for this case, I have put here in rows to watch as 20, but I would like to change that to 60. So please change this in the notebook from 20 to 60, and then the center 160. Basically, this is telling us the height and width that we are going to use of the image. Okay, so and then we apply this crop image function that we are going to reduce based on those parameters the size of the image to one size that is more or less manageable. So you can copy those lines of code, copy them, and then put them below inside the camera callback. So remember that about the indentation. Remember that the indentation has to be in line with this try and this except, okay, in order to work. So what we are getting is getting the shape. So from the image, we are getting the height and width, and then we are converting the image into a smaller one, doing this mathematical operation and acting over the arrays of the image. Okay, so once we have the image scaled down, we need to convert it from RGB into HSV format. So the image that is produced by the ROS is RGB, and then once we have RGB, once we convert into CB image, we have converted into BGR. It's a little bit different, but more or less the same, okay? Now we are going to convert into a different format again, which is the HSV, which it's the HSV, it's an encoding system that allows us to make the color detection more independent on line conditions. So basically it's eliminating the saturation of the image. So that's interesting because then we can apply the same method in different light conditions, basically. And how do we do that? Well, OpenCV, as is the same case as before, provide us with the function already done. So you can only copy this line, copy that, and put it below. So as you can see here, we are generating the HSV image, which is in a different format. And HSV's image is getting as a parameter in the function to convert the crop image. So this is the crop image, which is the smaller version of the image captured that we are using, that we have created in the previous step. And then we say, please convert into this format. Okay, so now we have HSV format, but we want to make it simpler to detect. So on this HSV system image, we would like to convert this image into a black and white image, in which the white indicates the location of the line, the color of the line that we are trying to follow, and the black is indicating I don't care. So that's any other space in the image with any other colors that I don't care. So I will have a very simple image which is in white and black only, in which if there is only black, it means that there is no line on the image, and if there is white, then it will tell me in which location of the image is the line. Okay, so that's why we want to do that. And how do we do that? Well, by applying a mask, and this is done by using some functions also that are provided by the OpenCV, of course. So it's basically is this one, which is here, is this function here, which is in range. Okay, so in this function in range, what we are doing is providing the HSV image that we computed on the previous step, and then two limits. So those limits are the HSV values of the colors that you want to detect a line between. So it means is in order to detect lines with different tones of yellow. So you want to allow like a certain amount of tones, and so for those tones, so you will provide the two HSV values for the lower yellow that you would like to detect and the upper yellow that you would like to detect. Okay, so now we are going to see how to compute that. That's a little bit tricky, but let me explain you. Okay, so don't copy this code here where it says in 30. Don't worry about that. This is another, I'm going to explain you what is this, but it's not the code that we need to put into our program. So I'm just trying to explain you how to compute this mask that contains only the whites and the blacks. Okay, so it's using this in range function of OpenCV, provide the HSV image and the two tones of yellows between which you want to have this the detection. So it's going to be detected and it's going to be put into white, and all the rest is going to be put into black. So how do we get that? Okay, so first thing, we need to identify which one is our yellow line that we want to follow. So if we go here, so you can see this yellow or greenish yellows, I don't know, I call yellow. I understand that has some tones of greenish also, but okay, let's call it yellow. So what I did was to capture the color, the RGB color values of this line in the center, and then the values were the ones that you can see here: 217, 255, 217. Okay, so that's one. Then I need to convert this into HSV because, as I mentioned, those functions are applying into an HSV image. So in order to convert any RGB value into an HSV value, you had to use this program here. So basically what I did was to put those numbers into this program, and then I got printed the values in HSV format that are equivalent to this RGB. Okay, so these RGB values, let me repeat, these RGB values are related to the color, are the RGB values of this line here, of this line in the center. Then I put it here in this function, which calls this function and converts into the HSV values equivalent, that are those ones. Okay, so now those are the values that I'm going to put in order to compute the lower yellow and the upper yellow. So how did I do it in order to compute those limits? Very simple and very stupid rule. Okay, so for the lower limit, I just subtracted 10 to every one of the components, and for the upper yellow I added 10 to each one of the components. That's it. That's how I computed those values. I'm sure that there are more sophisticated methods, but this works. So I can tell you that this works. So then what do we need to include into our program? So what we need to include here below the HSV computation is only this code here: upper yellow, lower yellow, and then the mask. So it's going to compute the mask. So copy that and paste it here below. Remember the indentation below the HSV. So I have my upper yellow, lower yellow, and then I compute the mask. Remember, the mask is the image that contains only two values, white and black. White is the place in the image that has the line, and then black is the one that doesn't. Okay, so now at this point in time, if the robot is seeing any image like we have here, okay, let me show you on the RBs. By the way, so having the RBs here is a pain because too many windows here. So at any point in time, you can detach this window from here, and put it into a new tab here on the browser by clicking on this icon here that has two windows. So if you click on that icon, then it's going to detach and it's going to show me the graphical tool, the RBS, in a different window. So it's loading, service unavailable. Okay, so some problem. Let me see, let me refresh. So that has to work, sorry. Come on guys, come on. Okay, so that's stupid, I don't understand. Why? Okay, so there was a problem here in my ROS jet. Let me reload. Yeah, it's not loading at all. Okay, so let me try again. So I'm going to launch again the graphical tools. And let me see if I didn't lose. Okay, so I don't know what could be happening here. Let me check on the terminal if I crashed for whatever the reason the RBS on the other terminal. No, here it is. So it is running correctly. The gazebo simulation is also here, running, no problem. Okay, let me refresh that. Okay. Okay, so let me continue and we'll see later, okay? Because otherwise we are going to lose our time in these stupid things. Then, yeah, so now at this point in time we have this mask that I mentioned. Then what we are going to do is to compute from the white part that is on the mask, which one is the center of that blob. So we call this white area a blob. Is an area that belongs to the same concept, whatever it is. So it's a blob which is in white. So what we are going to do now is to compute which one is the center of that blob. So we can know in which point of the image there is the center of the line that we want to follow. So for that we are going to use what in OpenCV is called the image moments, and that's a little bit complex to explain, so I have included here the documentation specifically of the moments. But basically what we are doing is calling this function that is moments, to which we provide the mask, which is the mask the one that we have provided before, and then we apply the moments in order to compute the two coordinates in the image, the CX and the CY. Those are the coordinates in the image, the X and Y coordinates in the image, that provide us with the center of the blob, of the whole white area that we have computed in the mask. Okay, so basically that's the way of doing it. You can check the documentation later and investigate a little bit more about how it works. So you can copy this and then put it below the mask code, and always remember to keep the indentation, okay? So remember, this is important, otherwise it's not going to work, the indentation in Python files. Yes, so now at this point we have the CX and CY values, which provide us with the center of the area that contains the line that we want to follow. Great, so now we know in which location of the image that the drone is seen, then there is the line. So we can make the robot turn towards that area. So if the CX and CY are not in the center of the image, then we are going to apply a certain rotation to the robot, so the robot can rotate and align itself towards the center of the line. So that's the trick, the simple controller that we are going to apply to implement here right now in order to move the robot towards the center of the line. Okay, so what do we need to do here? We need to do three things. First thing is we are about to finish, okay? So stay with me because almost finished. So first, we need to import the twist message. The twist message, remember, that is the message, the kind of message that we are going to use for sending velocities to the drone. So copy this line from geometry, copy that, and go to the top. Go to the top, and then include that line there. So remember, this is basic ROS basics. So that's why I mentioned that you should know ROS basics in order to do this live class. Then next thing is that we are going to include a publisher into the constructor of the class. This is the publisher that is going to allow us to send velocity commands to the drone. And then this is the topic in the drone that is accepting velocities in the form of twist. So please copy this line. This is a typical publisher, okay? So there is nothing more here. So select the whole line, copy, and then come here to the init, here, the init function, that's a constructor, and paste here that line. So now we have SpeedPub, which is a publisher into the command bell. Great. So now what we are going to continue is in the callback to compute the speeds that we are going to send to the robot based on the CX and CY. Okay, so based on that, we are going to compute those velocities. Then what we are going to do is the following. First, so let me copy, is the code that you can see here. Okay, so let me copy all that and put it here on the, well, no, I'm going to explain you from here. I think it's clearer. So what we do is first, we compute the error in the x-axis between the CX position, you know the CX position is the position in the x-axis of the center of the blob, and the center of the image. So in width, we have the image width. Remember, we computed it here. We computed it here when we asked the shape, so we have the width here. Then in this width, half of the width means the center of the image. So how far is this CX from the center of the image? And this is the error. Then we create a speed command, a twist speed is a twist, and then we are computing the linear velocity towards forward, to move forward, and the angular velocity, the rotational one, based on this error. First, for the linear, it has to be always on the x-axis, of course, because the robot is moving, we want the drone to move into the x-axis. So the x-axis is like the face of the robot, so it's moving forward then. And then we are applying just a 0.2 meters per second as default. So the robot is going to move all the time forward, 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 forward. Then the only thing that we are going to change is the angular z based on the error that we have computed. And we have put here this formula, which is the error divided by 100. So it's going to be the speed at which is going to turn. And this is a very stupid P controller, very, very simple P controller. And that's it, very simple. It's just for the matter of this example, not for anything else. And then, so what we are doing is sending the speed to the robot. That's it. That's all that it is. So let's copy all this code. Let's copy it and then come here to the below the part of the computation of the centroid, and let's add it here, taking into account the indentation. Remember, okay? That's important. So that's it. That's it. We have it here, everything, and now it only remains that we run it and see if it works or not. So if everything is correct, let me open. So this terminal is already with Arbis, this other terminal is free, so let me put it here in another location so you can see the results here. Then what I'm going to do is to launch the code. How do we launch it? ROS run line follower, the name of the package, and then the name of the binary, controller.py, controller.py. Okay, let's see what happened. So because I lost the RB, so okay, I have one problem. Oh, but still the robot is moving and following the line. So what is this problem here? Okay, but anyway, the robot is moving, and you can see it's doing a lot of oscillation, of course, because the values of the P is very bad. So I just put this 100, but you can reduce this value, I mean increase this value, and then avoid the oscillation. So you can see here how the robot is following the line on the here. I don't know what it's going to do. I don't know if the image is able to capture these values here. I don't know. We'll see. Okay, no, I see it doesn't. So for that, we need to see the image in ROS in order to see that. But anyway, you saw that how the system was running. So let me know if it works in your case or not. And in the meantime, let me check this error here. It says bad callback, camera callback, blah, 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 blah. Speed publish, raise exception. Okay, yeah, I see. It's because, I know, so is this init node here, I put it here, and then it has to be before. Okay, very stupid thing. So this init node in the main is done before, it has to be done before the line follower is created. So let me put it before, there it is. So now is that stupid? So it's only a problem at the beginning, but yeah, but that's why it created this error. Okay, so let me know if it's working in your case. So please let me on the chat if it doesn't work, guys. Okay, Elisa has a problem that says name self is not defined. This means that you are putting some code outside of the class. So self, remember self is because this self, I don't know where you are getting that specifically, but this self, it's indicating the class, the line follower class. So very likely that you have put the self outside the class in some place around here because of the indentation. And Connor says uncheck image in RBs is having RAM issues. Okay, yeah, that could be because it's because of the instance that we have here that has only 8 GB of RAM. And yeah, that could be that we have launched too many things, but in my test it was okay, so there was no problem at all. So let me check later when we finish the class. Then Nishan says it's working fine. Wodonghu is also, it works, very good. Then Bashir says I got indentation error and an indent does not match. Yeah, so that's a problem I'm telling you along the whole class is about this indentation. You have to pay attention into that indentation. This is very, very important in ROS, in Python, sorry. So in Python, you have to keep the indentation. You cannot put whatever the number. If you put one space here more, then you are going to break the code and it's going to give you those details. Please review the whole code and check that it looks like the one in my screen. You see on the screen you have this class, so you have to see those lines that go straight down. So those lines are the ones that are indicating your indentation. You shouldn't have those more than those. There, check it. Viet Han translate, it works. Very good, Viet Han. I'm so happy. Then we have Oscar, how can I stop my drone? Yeah, okay. Yeah, in order to stop, you had to send a 000. That's right, that's right. It's moving, it's keeping moving. So then Curtis Newton says, image became gray, not working anymore. When I was working, the robot was not following the line at all, but I see the point. Oh, sorry, Curtis, for that. I'm happy that you understand the point. And you got some problems. Okay, I would like to know more about that problem. Okay, Thomas, works fine. Very good, Thomas. Elisa, it's the CB bridge, self C bridge object. Okay, all right, you're right, Elisa. Thanks. Okay, thanks, Elisa. Got it. Great, Elisa. Lagan Kapoor, working good. Very good, Lagan. I couldn't expect less from you, Lagan. Then Ayman says, can I have the code so I could start? Yes, the code is at the top of the most of the top of the chat, you will see the ROS jet. You can get it there. The Curtis says the environment is one unstable crap. Okay, Curtis, don't be so bad with our environment. It's very, very nice piece of work. Imagine having 200 now at present 240 people practicing the same code, the same thing at the same time. That is, nobody else can provide you this, only us. And so that's not to say unstable crap is too much. You can see is too much. But okay, accept the criticism. Mehdi says he's happy, so probably I understand it's working. Guess me, Sado, hi. Navi Pico, please try to send the class again. Thanks so much. Okay, let me go and launch it again. So I'm going to press on this button here on the icon wall. Then I'm going to show you my list of ROS jet, and then I'm going to put it on the chat again. Lagan says, then let me see, thanks a lot. Okay, it works, thank you, by share. Okay, Mehdi is just rotating. Okay, check your code, it has to work. Also, check, it's very important that you check in which location you have put the drone. So you have to be able to see that the robot can see on Arbis, can see the line. If otherwise it's going to not to see, and it's rotating. Well, it has to rotate and move at the same time forward. So here the ROS jet code again. And yes, try building such an online platform yourself. That's engineering nation. And then, okay, thank you, engineering nation. Curtis, we accept the criticism. We are working very hard to make it more stable. I can tell you, we are about to release a new version in the short time. Then let me tell you that if you have finished the point here, so you have reached the location, and here the homework, sorry, is wrong. It's my mistake, it's the wrong. So in the homework that I want to send you is that you create a PID controller for the drone. So the drone follows the line smoother, following P, D, and PI and D variables, values. And at present, I only put a P, a proportional, based on the error, you know? Okay, and then please, if you like this video, please support us, guys. You have to support us so we can keep doing those super cool classes. How can you support us? First one, subscribe to our online academy. It's called the Robot Ignite Academy. And then we have a lot of courses that are run on the browser, so you don't need to install, and you are practicing like here. For example, I would like to recommend you this ROS Perception in 5 days, which is a course which explains all this about OpenCV and many more things. So if you click on this link, you will get into what it contains directly inside the Robot Ignite Academy. And you're going to see that it teaches you how to detect people, how to follow people, detect faces, how to detect obstacles, how to recognize, train for your obstacle detection, and so on. And having here some issues with the internet, trying to connect. Well, anyway, if you don't want to get into our academy, then you can also support us by buying one of our ROS developer Macs or t-shirt. Check our merchandising area here. And finally, if you don't want even to buy a super nice mug or t-shirt, you can give us a like and subscribe to our channel because it's completely free. Come on, give us a like to this video, subscribe and press the bell, because if you press the bell, you will be notified when we release new live classes. We are preparing, for instance, a full week again of training that is going to be done next week. But I'm not going to tell you more details because I want you to be paying attention to our channel, okay? So please subscribe and press the bell so you will be notified when we are going to relaunch this whole week of training in ROS for next week. and it's going to be for free, like this class also. So guys, so I see that there are so many things there, but then I cannot do it. So I wasn't expecting so many people, 240, that's the one I have seen, the peak. And usually we have 40 people, so I'm so happy that you are here, and I hope that you learn a lot, you practice a lot, and you can check that later, even the project, download to your local machine or execute on the cloud there, and learn a lot more on that. So I'm super happy to have finished here. I had to finish here. For next week, we are going to have a class on DDS. So we are going to see the basics, what is DDS and how to test DDS for ROS 2. So it's going to be a very introductive class, and we are going to do some experiments with ROS 2 using the ROS Development Studio too, because Connor, you know, the ROS Development Studio can also launch projects in ROS 2 and in ROS Melodic, in ROS 2 in 2 versions different. Wow, that's super cool stuff. So you will see that next week if you attend, you, Connor, and all the other people. Again, I'm going to be happy to have you all here. Thank you very much, guys. See you next time, and until then, keep pushing your ROS learning.